as a developer, we don't want you to have to do anything differently. We don't want people to have to think about, oh, where am I going to get my GPU from? Or like, how do I have to change what I'm doing to get the GPU? What we want to do is let everyone do what they already do, but then just use the hardware more efficiently, fully behind the scenes. So everything runs as you would normally expect, and then you don't have to think about what's going on. But we're able to use these GPUs more efficiently, and then all of a
Mm-hmm.
sudden the cost of accessing GPUs just comes way down, because instead of each GPU serving one person, now you can serve 10 people with that GPU.
Gumbo listeners, this episode is brought to you in part by OS Nexus is an industry leader in software-defined storage, helping you maximize storage platforms like Ceph and OpenZFS. Choose the easy way to manage your storage and reduce costs with less effort. Go to osnexus.com to get an expanded community edition now. Welcome back to another episode of Data Protection Gumbo, where we break down the latest innovations shaping the future of data protection, computing, and AI infrastructure. And today, we're diving into a topic that's at the cutting edge of AI and cloud computing: why every GPU will be virtually attached over a network, right? It's something that you need to think about because it's coming and it's happening right now. To help us understand this massive shift, we have a special guest on today, Carl Peterson, and he is the founder and CEO of a company called Thunder Compute. No, it's a pretty cool name. And they are revolutionizing AI infrastructure by making GPUs network attachable. But Carl, welcome on. How are you?
Doing great. Thank you for having me, Demetrius.
Awesome. So let's start from the beginning here. Can you share how Thunder Compute got started and also what your journey through Y Combinator was like?
Totally. Yes, we started classic startup story out of our college dorm. It was me and a couple of college buddies just talking about ideas, like sitting there on a whiteboard, thinking about potential startup opportunities. And my friend and now co-founder Brian came in and was talking about his experience in his lab where he was doing ML research, and everyone was signing up for GPUs with an Excel sheet 2 weeks ahead of time. And with that, people would reserve blocks that they wouldn't use. Their research would be bottlenecked by trying to get GPUs, and they'd have to wait weeks to actually get them. And that led us to first come to the realization this isn't sustainable. People are spending millions of dollars on GPUs, billions of dollars, and they can't get them, and they're not being efficiently allocated.
Mm-hmm.
We started digging into ways to make that process better, and we'll go into way more depth here, but we landed on this one virtualization strategy where you're network attaching GPUs, and saw this as an opportunity to dramatically improve utilization of these expensive resources. And I think we can really change the world with what we've built.
Yeah, I really think so, because I was not thinking that way when I was in college. And so it took me, I took the long road. It was a journey for me in order to just walk across that stage. So I definitely take my hat off to you and Brian.
Exactly.
Okay. And I want to dig in just a little more on the Y Combinator experience and also talk a little bit about what that was like, because I know it's known for pushing startups to move fast and also think big. But what was the biggest lesson that you took away from that experience, Carl?
Yeah, I think by far the biggest takeaway is startup founders are normal people. And it's not a crazy thing to go found a startup. And I think the reason I say that is you show up and you're surrounded by hundreds of other people who are doing the same thing. We're working like normal people jobs, and then just saw something where they got the itch and were like, I think there's a huge opportunity here. I think I could build something really cool. And then they just went off and did it.
Yeah, you make it sound easy, but not quite that easy. Because especially in your 20s, you have to be really focused to really hunker down and do something like that. But I guess if it's your passion, and then I can totally understand that. And there's a lot of talk around AI infrastructure, and we know it's a very highly competitive and technical field right now. And when DeepSeek dropped what they dropped, and I've heard something about Manus as well. Not sure if you're following all of this stuff, but I'm sure you are because it fits right into your space. But where does Thunder Compute fit just in the overall space, and what sets Thunder Compute apart?
Totally. So we sit a layer below all of the AI models
Okay.
and all of the implementation of those and kind of everything with ChatGPT and Manus and all of the new model advancements that are coming out. And what we're doing is taking GPUs, which power all of this, and then using those more efficiently. So NVIDIA has a stranglehold on the whole GPU market, and they
Yeah.
sell out years in advance. They're 95% of the GPU market. And people are buying these GPUs to build these AI models. But what we saw and what some other people have seen is the GPUs aren't fully being utilized. Like there are a whole lot of GPUs that are just sitting there doing nothing. And that's because of this technology layer where we sit at. And it's just like hard to take all this GPU capacity and efficiently give it out to everyone so that you're making sure that these really expensive physical chips are actually used all the time.
You have any thoughts on DeepSeek and what it did to the market or to the world? I don't know
Lots
if
of
you
them.
want to share anything or not.
Yeah, I think DeepSeek, regardless of how much compute they actually used, I think they put out some pretty crazy numbers. It may or may not be true of how many GPUs they used. I think it is pretty agreed upon that they used fewer GPUs than OpenAI has used to reach similar results. But I think what they did show is there isn't much of a moat at the foundational model layer. And all these companies are in like a tight race to build the best model. But then if somebody else comes along and builds a better model that's cheaper, all of a sudden you have to cut your prices. And I think that will continue. Like models will continue to get better, prices will continue to come down. And if you're running a business that relies on these models or wants to use AI, like you should bank on prices coming down. You should bank on access getting easier and models getting better. And I think those are pretty certain bets.
Are you familiar with Moore's Law?
I am, yes.
Is that still relevant? I was watching I think it was a short documentary, and they were talking about Moore's Law, and I think he worked for, was it IBM? I can't remember. I'm losing my memory here, but they were talking about him and his law. Basically, they were saying that computing power or chip strength increases every 2 years it was, but maybe we're hyper advanced now where it's accelerated a lot faster than that. And it's probably every day, every other day, you just sit back and wait and something has dropped new that, everyone or no one was paying attention to. What are your thoughts on just the acceleration of AI? And also I wanted to throw a twist in there around jobs, right? Do you see the acceleration of AI advancing so fast and so quickly that it's going to eat into, let's say, the white collar jobs, like what I do day to day, the tech workers?
Definitely. Yeah, there's a ton to unpack there. And I think Moore's Law, referring to computer hardware, there was talk that Moore's Law had started to die for CPUs specifically, like the doubling of capacity, I think, every couple of years, or
Yeah.
doubling of processing speed every couple of years. But Jensen Huang has said this, that what has maintained Moore's Law or even sped it up is shifts in the type of hardware that people are using. And the shift from just CPUs to accelerators, and GPUs are a type of accelerator, has actually exceeded what you would expect from Moore's law. And it's not just by making CPUs better, which is what Moore's law used to say. And now it's by changing the type of chips that you use and using more specialized chips for specific tasks, or using like GPUs for AI. And then now we're seeing AI specific hardware, which is even more
Right.
efficient than GPUs, which are general purpose. And I do expect that to continue. And there's a lot of talk about quantum computing and whether quantum is here or not. That could be the next step in having hardware that's even more efficient for the tasks that we're trying to accomplish. And then on the AI acceleration front and like the capabilities of these models, I do think models are continuing to get better, and the speed that they're getting better has accelerated rather than slowed down. How much that continues in the future, I think it's up in the air. But I do think models today are good enough to replace somebody's baseline knowledge at most things. If you take the frontier AI models and compare it to my ability of accounting or like legal, or like if you look at any specialized discipline, like the models are very close to the top performers in a field, if not better. Where they do lack is agency and like the ability to remember something over a long period of time. So like right now, a human is much better at looking at a large system and kind of learning how things work and then piecing together experience from their past to make a decision. And I'm not sure if models will become better at that than humans. They totally might, but at least today that's where the gap is between like a model's capability and my capability. Is I can do a task for an entire day and remember different pieces of it and see what I learned, but the model can only look at the context of a point in time. And if your chat history gets longer than a few messages, it starts to degrade in quality.
Yeah. I'm thinking somebody will, it may already be some kids in a garage in California, or it could be in Georgia. It could be anywhere now, tinkering around with an idea, because a thought popped in my head around ChatGPT is not really able to remember much within like another prompt. If you type in something and you start working within that prompt, then it's only going to really remember what's in that prompt. But you have a history of prompts, right? So you can go back and click in at any one and say, okay, I want to get more information about this one. I'm thinking that, okay, someone's going to have something where you can maybe agentically, right, take all of those threads and then be able to pipe that back into a response where it can just keep going in a loop, running the task of all the history and information in there. But maybe I don't understand it enough to really sound like I know what I'm talking about on that.
I do think that's right. And coding's the place we're first seeing this. Cursor is the biggest name that started to build
Cursor?
this. Yeah, so they're a startup in the Bay who's built like an IDE, which is like a VS Code fork with just AI baked into every part of it. So like a code editor that is fully AI native, has full knowledge of all of your code, and then can draw on that. And what they've been able to do is take a large code base and then split it up into chunks that AI can reference and search through. And they've really extended the capability of what these models can do. And they're the fastest growing startup in history. They hit 100 million of ARR within 6 months. So
Okay.
there's huge demand for this. They've very quickly reached widespread adoption and have had a pretty large impact. And then you've also started to see other coding agents with even more ability to go through code bases and maintain context. And Claude Code is really the first widespread one, which is Anthropic is OpenAI's like probably best funded competitor right now. And they released their model Claude, and then Claude Code is the coding agent based off of that latest model. And Claude Code has been incredibly impressive. I've actually used it a fair bit, and it's still expensive, but what it's able to do is really work with itself almost and run experiments. And it can write a piece of code and then compile that and run it and then see the output and then see what went wrong and then go back and edit that. And it's able to string together all these actions much better than you've seen in the past. And a lot of times ChatGPT will spit out a block of code. You try to run it, it breaks. You ask ChatGPT to fix it, and it just gets lost and can't do that. Claude Code has been able to actually improve on itself. And I do think that we'll continue to see agents that are better at that.
Let's see if we can break it down a little bit for the listeners now. What does it mean for GPUs to be virtually attached over a network? And how does this differ from, let's say, traditional GPU configurations?
Definitely. Yeah. So the root problem here is you have all these GPUs that are sitting there in a data center, and you have a whole bunch of customers who want GPUs, and you have to figure out, okay, how do we give each GPU to each customer? And right now, what happens is every GPU is plugged into a server, and then the customer uses that server. Demetrius is running their AI model. You would take your AI model, put everything on that server that it needs to run, and then you'd have access to the GPU. But what happens here is a lot of times we have people who are using servers but not using the GPU, or they're only using a part of the GPU. So that GPU is exclusively reserved for Demetrius the whole time you're using that server. And we're not able to give that to someone else if you're not using it, or we're not able to give a piece of it to someone else if you're not using all of it. And that's where network attachment comes in. Like, instead of that GPU being physically plugged into the server that you're using and only reserved by you, we can now take that GPU and give it to whoever needs it. And we can give pieces of it out. And what that lets us do is take these GPUs, which are really the most expensive part of this whole setup, and put them wherever they're needed most. So if, Demetrius, you need one GPU right now and you're using all of it, then you would have that GPU. And then if in 10 minutes you don't need any GPU, we could take that GPU and give it to someone else. And then if you need 10 GPUs in the next 10 minutes, we could give you 10 GPUs. And it just makes a much more flexible system where we can take this capacity and put it wherever it's needed.
And yeah, it sounds a little fascinating. So many things were flashing through my head. So this is software. Are they logging into like your portal or something and then doing some configuration?
So it's actually not. Like, you don't have to, as a developer, we don't want you to have to do anything differently. We don't want people to have to think about, oh, where am I going to get my GPU from? Or like, how do I have to change what I'm doing to get the GPU? What we want to do is let everyone do what they already do, but then just use the hardware more efficiently, fully behind the scenes. So everything runs as you would normally expect, and then you don't have to think about what's going on. But we're able to use these GPUs more efficiently, and then all of a sudden the cost of accessing GPUs just comes way down, because instead of each GPU serving one person, now you can serve 10 people with that GPU.
So how do they take advantage of, how do they actually utilize your software or Thunder Compute? How do you utilize it?
Totally. So what we do is just sell GPUs that, from the developer's perspective,
GPUs. Okay.
Exactly. They look the same as what you would buy anywhere else.
Physical GPUs.
Virtual GPUs. Yeah.
See, I was trying to get you to say virtual GPUs, right? Because you have GPUs, and then let's say you buy 5 GPUs and you have them all running at home or somewhere. You have access to them. You have them all configured with your super secret smart configuration on the back end. And then you figured out a way, okay, we have these 5 GPUs. So now we're going to let people purchase one little teeny smidget of GPU processing power, so they can do what they do and get information back from some of these LLMs and whatever models that they're working with. Is that right?
Exactly. Yeah. So you can come to us, rent a virtual GPU, and you can use however much of it as you want. And it's just way cheaper than if you were to rent a physical GPU. And our goal is for that to be identical. Like you don't care if it's physical or virtual, but it's just way cheaper and just as easy, if not easier.
So if
Yeah.
Demetrius wanted to, and I don't know anything about building my own LLM, I really wanted to sit down and maybe watch a YouTube video or two and create my own private little large language model here and then load all my information in it that I want to train it on. Is this something that an individual like myself or anyone else out there can just say, okay, you know what, maybe I want to purchase some GPU power, right? And is that expensive, or can someone like me afford it to maybe get, what's the smallest unit?
Totally. Yeah. So everything is, the way it's charged now is hourly. So kind of,
Hourly.
yeah,
Okay.
everything is just based off of the time that you rent the GPU. But yes, anyone can access this. You just sign up with your Google account and click start. We try to make it as easy as possible. And then we even have templates that people can use that already have models loaded. So if you want to run a vision model where you're generating images, or if you want to run an LLM and like experiment with that yourself, like we have templates that have everything pre-installed that you need to play with this. So this is our homepage. We have the GPU prices front and center because really what we're doing here is adding this software that makes GPUs way cheaper and way easier to access. So these are data center GPUs. Like you might hear talk in the news of NVIDIA making hundreds of billions of dollars from their data center GPU sales. And these are the cards that they're selling. So for example,
Rodwell.
one of these would cost $30,000 to buy, which is why you would rent access. And if you're somebody who wants to experiment with a model, a lot of times you need these really large GPUs to be able to actually run the model. And then you would go to a cloud platform to rent it. So instead of buying your own, setting it up for $30,000 to $50,000, you could come to us and rent this for 80 cents an hour. And we give you $20 of credit so you can run it for 30 hours or so for free, and really experiment with what it actually looks like to use these. So if you log in, this is the place where you go to actually run anything you want to run. And you can create a cloud instance with this button, which will pop up the options that you would want to use. And there's like an A100 is a smaller data center card from the A100 80 gigabyte, which is quite a large one. And if I start with this, you can customize what actually goes into that cloud instance. But really, this is just speccing out what you want in that server. And then once you click create, you'll get those resources. You'll get the GPU, the CPU, and then this is where the magic happens. This is like the templates to run different models that you would want to run. Or you could just get a general purpose cloud instance where you can run anything. And this is like basically a computer that has the GPU, and anything you want to run can go in there.
Okay.
Yeah, I'll pause there for a second. Any questions so far?
Yeah, so for someone who has never created an LLM, is it as easy as that? So when you go in and you select the GPU type, number of cores, and the template amount of storage that you need, then boom, it pops up like a, let's say, a virtual machine or something. And now it takes you to this command prompt where you can start typing command because now you have the hardware and GPU sitting behind it. Is that what I'm thinking?
Exactly. Yes. And that command prompt is like your own computer, essentially, that has the GPUs.
Okay. That is pretty cool.
Thank you. Yeah, we try to make this as easy as possible because we find with existing tools, there's just a ton of extra complexity. And if you go to AWS, like it's built to serve massive enterprises who are doing a whole bunch of stuff besides using GPUs and running LLMs. So it's just very complicated to get anything set up because they have to support all of this. But if we're building this just to run AI and just to experiment and get started quickly, Like we can cut down a ton of that and then just give a really easy interface.
And so you mentioned Amazon. How does this compare to Bedrock or let's say Azure OpenAI?
Totally. Yeah. So Bedrock fits a different niche.
Okay.
Bedrock gives you like a pretty restricted environment where you can do very specific things very easily. If you want to set up an app and use one of the pre-built models in Bedrock, you can put that model behind your app and pay per request. And that's an easy and quick way to get set up. But if you want more customization and you want to run the model from scratch or have your own UI or use other existing tools, you need access to the server itself. And that's when you would come to us. Or Amazon has EC2, which is their virtual machine or like server rental business. And
right.
This is like a direct alternative to EC2 rather than Bedrock.
Okay. I'm glad you changed my mind frame on that because I'm just thinking AI and I should be thinking virtual machine.
Exactly.
Okay. All right. You set me straight. I
Totally.
appreciate that. Now, do you already have an instance created?
So I do. I can just create one here too. Would
Okay.
you rather run an LLM or image generation?
LLM is what everyone knows right now.
Perfect.
Including me.
So let's do this. And then this will create the cloud instance. And now you can see it here. Provisioning. And basically what we're doing behind the scenes is we're actually wrapping Google Cloud and Amazon, and we're just putting our software on top of that. So we're renting GPUs from someone else and then using them more efficiently to make them cheaper. And then you can rent them through us for cheaper. But actually, we're just creating a virtual machine within Google Cloud right now.
You have any stuff in Azure?
We do not right now. We plan to down the line.
Okay.
Yeah.
That is very cool. So it's going to create that. How long does it take?
Yeah, it varies depending on
time of day,
how much capacity Google has, and the time of day. But this is like usually 30 seconds to a minute. And what they're doing is they're actually doing a whole bunch of hard stuff under the hood where they're looking at all the servers they have running and finding where they have room, and then also checking like are there several people on this server? Are there enough CPU cores available? Is the networking saturated in this region? Is like the power out on this server rack? And like that's all stuff we don't have to worry about because we're just renting through them.
Yeah. Okay. But this is pretty cool. I appreciate you sharing I guess you sharing with us how exactly this looks. This is really awesome. And maybe close us out with the one thing that everyone is also talking about as well, which is one of the biggest concerns. And that's around, I guess, network attached GPUs. What about security, cybersecurity? How secure is this? And so I guess with so many GPUs being accessed remotely over the network, are there any like key concerns around security and data integrity and maybe how that can be addressed effectively?
Definitely. Yeah. And what we do for security is make sure all of the data is as constrained as possible so that there's nothing leaking out where it doesn't have to be. There's nothing getting stored that doesn't have to be stored. So the kind of what we're doing under the hood is like taking a normal VM and then attaching this GPU over the network. So the piece we're adding there is the GPU that's attached over the network. And from a data security perspective, that's where we're looking. So the VM on its own has all the same security features as standard VMs, and those are all very well established at this point across the industry. And then what we're looking at from that tunnel between the VM and the GPU is like making sure all of that data is encrypted that we're sending back and forth. We also make sure that all of the data on the GPU is restricted to you, and then anything that gets sent isn't stored over there. It like just stays in memory, is deleted immediately. And then that is like another layer of protecting your data. On top of that, if we're passing this GPU off between people, we want to make sure that everything is fully cleared as soon as that GPU is used by someone else.
Yeah.
This isn't something we do now, but eventually down the line, we can share a GPU at a point in time between multiple people. And then the big consideration there is like making sure everyone is fully isolated so that one person can't read someone else's data. And those are the types of things we think about, is just making it as close of an experience as possible to just the secure VM that you already have.
Okay. Carl, this has been an absolutely fascinating discussion. And so before we wrap up, where can our listeners find out more about Thunder Compute and also your work?
Certainly. Yeah, our website's the first place to go. And my biggest recommendation is just try it out. If you have ways for people of all levels to get started, whether you're tinkering with an LLM, like I just showed you how to set up, or if you have a company and are moving an entire team to us, we have ways for you to do that too. But then beyond that, there are some blog posts on our website, and then through Y Combinator, you can read some more as well.
Do you have a blog post out there to walk someone through creating their own small LLM for their own home needs?
We do, yes. So we have guides in our documentation.
Okay.
And it's like thundercompute.com/docs. And in there, you can see guides on, I want to run DeepSeek. I want to run like stable diffusion to generate images. That's all in there.
And I don't know if you can share. What type of crazy LLM do you have set up? I'm sure you have something that you're running personally that's mind-blowing. Can you share? If not, that's fine.
Yeah. DeepSeek's the big one. It's like the best open source model out there right now.
Is it safe though? Because people are like, really, China, when it's just not secure and you don't know what they're installing on your system. And I've even heard that it's doing a hive thing behind the scenes where each person that accesses it, all that information goes back to the mothership. I don't know, it was like a Black Mirror episode, which season 7 is coming out, I think on April something. It's coming out really soon, so if you like Black Mirror, you might want to check it out too, Carl.
Totally, yeah. That's the advantage of hosting it yourself with us, is all of it's offline in your own server, and you have full protection of the data that you're using. If you're using DeepSeek's hosted version, they can do whatever they want, and they likely do. They likely read all of your chats, use them for training data.
Okay.
I'm a big proponent of self-hosting. That's the service we offer too.
Okay, so you got something built there that you got your own LLM where you can go ask it, hey, what's the temperature going to look like tomorrow in the basement? And it just kind of gives you all the information and constantly learns from that. But all right, yeah, this was really exciting, and thank you for spending some time with us here today on Data Protection Gumbo, and also shedding some light on what I think and what I see is a major shift in AI infrastructure. And also to our listeners out there, if you enjoyed this episode, make sure to like and subscribe, and also share it with your network. And that's it this week on Data Protection Gumbo. Carl, thank you so much again for being a guest here.
Thank you, Demetrius.